Hi everyone, my name is Wan Hazkaliana binti Wan Abdul Aziz. My metric number is DI230103 and I'm from section C, and in this video, I will be sharing of my reflection on what I have learned about web service, particularly using the Goal Calculator Service project that I built and test using NetBeans and SubUI. Throughout this process, I have gained a clear understanding of how web service work, how they are described using WSDL, and how we can test them using tools like SubUI. So, to begin with, web services are applications that are accessible over the web using standardized protocol such as HTTP, XML, and SOAP. This service allows different systems to communicate and exchange data even if they are built using different technologies. So in my project, the goal calculator service takes two inputs, which is weight and price. It will calculate the total value of gold. This logic is exposed as a web service hosted in NetBeans. So this is the output of my project, goal calculator service, after I deploy and test the web service on my NetBeans. So here is when the user entered the values, current gold price per gram and weight in grams to be calculated. So here is the output. When a user invokes the count total price method from the gold calculator service, they are provided two parameters, the current gold price per gram CGP and the weight in grams WG. As you can see, the values used were 264 for the gold price and 22 grams for the weight. These values are sent to the web service in the form of SOAP request, which is structured in XML format. The SOAP request is wrapped inside the SOAP envelope tag, which is the root element in any SOAP message. Inside it, there's a SOAP body that contains the actual data being sent to the service. So here you can see the namespace count total price operation with the two child elements, which is count gold price CGP 264 and weight gram WG 22. This represents the input parameters expected by the service. When the SOAP SOAP request is received by the server, the service processes the data by calculating the total price as 264 multiplied with 22 equal to RM 5808. The result is the return to the client in a SOAP response, which also follows the XML structure. The response contains another SOAP envelope and SOAP body, and inside it you can find the namespace to count total price response element. This holds the return tag with the final output total price RM 5808 ringgit Malaysian. What this shows is a complete communication cycle between a client and the web service using SOAP. The WSDL file defines what this request and response should look like, and including the operation name, count total price, and the data type float for both parameters. Tools like SubUI use the WSDL to automatically generate the structure of this request, so users just need to input the values and run it. So SubUI just show whether the response was successful and displays the written output as you see here. Now, one of the most important parts of working with web service is understanding the WSDL file, which stands for Web Service Description Language. This is an XML that serves as a complete description of what web service offers. The WSDL tells us exactly how the service can be used. It includes the name of operations like calculate gold value, the types of inputs and outputs like float or double, the message structure, the binding protocol, SOAP, and the URL and point where the service is hosted. Without this, we wouldn't know how to call the service properly. That's why it's important to really understand the structure of WSDL. Inside the WSDL file, there are several key elements to look for, which is type that define the data type used, message describe the input and output data, port type list the available operations, binding tell us how to access the service using SOAP, and lastly, service give us the actual URL to send the request to. The WSDL 5 for the goal calculator service provide a detailed description of how the web service works and how it can be accessed. It begins with the definitions element, which is the root of the WSDL document. This element includes multiple namespaces and specifies a target namespace, which uniquely identifies the service. This is important because it allows different services to be distinguished from one another even if they have the same names for operation or data types. Next, the type section imports the external XML schema definition (XSD) file. This schema defines the structure and data type used in the service, such as the parameter for calculating good value like weight and price. This is essential because it tells the system what kind of data to expect and how to validate it. Next is the message element that defines the input and output for the service. In this case, there are two messages: count total price for the request and count total price response for the response. Each message consists of a part element that refers to the actual XML element, which is defined in a schema. This part must be present on the SOAP request, otherwise the service will not understand the message. Following that, the port type element acts like an interface. It defines the operation available in the service, which here is the count total price. This operation includes an input and the output, each referring the corresponding message. Essentially, this tells you what action you can perform and what response to be expected. Other than that is binding section that specifies how the service is accessed via the SOAP protocols. It tells us that the service uses HTTP for transport and that the message format style is document with use literal, meaning that the SOAP form message must match the XML schema exactly. This is critical for tools like SOAP UI to correctly format and validate the request. Finally, the service element defines where the web service is hosted. It includes a port element that ties everything together: binding, operation, and the address. HTTP localhost 8080/gold calculator service/gold calculator service, where the actual service is running. This is the endpoint of SOAP UI uses that to send the request and get a response. In SOAP UI, we use the WSDL file to automatically generate requests. By importing the WSDL URL, SOAP UI understands all the operation, expected parameters, and endpoint location. It gives us a ready-made interface where we can simply input values like goal, weight, and price, and then send the request. The response returned is based on the logic defined in the service. If the request matches what the WSDL expects, the response will be successful. Otherwise, error may occur due to missing or invalid elements. SOAP UI itself is mainly a testing tool. It provides a user-friendly interface where we can send requests and receive response. It's not where we build the system, it's just used to run and test it. When I run my request in SOAP UI, I can see immediately whether the response was successful or not. If the request is valid and match what the WSDL expects, the response will include the total goal value. So, in summary, the WSDL defines the operation, input and output structure, and the SOAP request send data to the service using XML. The service processes the data and returns the value, and the SOAP response shows the result inside the return element, and SOAP UI acts as the interface to test this flow by displaying both request and response by validation. So this is the entire process that demonstrates how web service communicate using SOAP, guided by the structure and rules defined in the WSDL. So in conclusion, this project has taught me how web service work at deeper level. I now understand how the WSDL acts as a contract that guides the client on how to interact with the service. I have also learned how to read and interpret WSDL elements and apply them in constructing valid SOAP requests using SOAP UI. Goal Calculator service is a simple but powerful example, and the same principle can be applied to more complex real-world service. Lastly, thank you for watching my reflection videos. I hope this explanation helped clarify how web service, WSDL, and SOAP work together in this lab assignment.